privilege to be here this morning, and that's kind of the diplomatic formality that one should say before every talk. In this case, though, I actually want to give you some reasons. Actually, there are several reasons. First of all, I believe that this topic is one of the most crucial topics in evolutionary theory today and in science and religion dialogue. And not just one of the large number, but I actually think it's one of the two most crucial topics, theoretically. The issue of directionality to emergent progress and evolution, and also the issue of the evolution of ethical capacity, and they're not unrelated, by the way. Secondly, it's just a privilege to be here because it's been a long time since I've seen a theologian dive into the primary literature in biology, and I'm just very impressed and very appreciative. And thirdly, actually, it's good to be here with friends who have been friendships that have been formed around the pursuit of shared interests and common vocation. So Neil spoke of the complexification of nature. In my response, I want to involve the nature of complexification. I actually want to dive into the data. Now, I have to say, Einstein says any fool can know. The point is to understand. So it's a temptation to just jump into understanding and talk about theoretical interpretations of the data, but I think that we have to get to the point of knowing first. So I'm going to spend most of my time actually talking about the data that informs the trends that Neil was discussing. I hope you enjoy it. I really wrestled whether to do that or to leap across to the theoretical issues of Neo-Darwinism versus alternatives. So what I'm going to do is three things. I'm going to focus on evolutionary trends, the empirical data. That's the majority of it. I'm going to say a few words about the interpretation, which would be the second part of Neil's talk. And then I want to close with some questions, some specific questions from Neil. First of all, I'll do two things here. I want to talk about Neil's approach, and by that I mean actually the literal approach, the way he built up speed to these questions, the three issues that he raised. And then I want to get into the issue of complexification itself and talk about not just generalities, but three major areas. And I'll go quickly with this. In fact, if I'm moving too fast, have a lot of and I guess I'll justify that by saying I want to give you a feel for the data. So first of all, Nils began with noting the issue of diversification. That's certainly a trend in evolution. And he also noted that more is different, but different isn't necessarily more. Well, I want to make two quick comments on that. First of all, we do have an undeniable trend in diversification across evolutionary history, but it actually depends on what taxonomic level we look at. So, for example, we have fewer phyla now than we did after the Cambrian explosion. So sometimes diversification at one level comes at the expense of attenuation at another level. And in fact, that's even true possibly morphologically. So in early cells, this is just a representational schema, you can have lots of parts. Then when you get metazoans, you have different kinds of cells with fewer parts. Now that's been a theory for a long time, and recently Dan McShane just published some work in which he tested that. He actually looked at metazoan cells versus protists and land plants versus protists, different cell types. These were indices of diversity, and he found that in every case, the more cells from more complicated organisms were in fact more simple. So it is true that difference doesn't actually equal more, but it actually isn't always true that more is different. Sometimes more is less different. Eukaryotes probably threw away 80% of the biochemistry used by prokaryotes. So that's an interesting data point if you want to think about complexification. Secondly, the multi-adaptive exploration of ego states, which Nils emphasized more than diversity. This is from a paper by Stanley Salty, and it's just true that over evolutionary time, organisms have occupied niches, morphological and ecological, that were previously unoccupied. What I'd like to point out, though, is over the course of, here we have evolutionary time, over that course, there are all sorts of changes going on in the abiotic environment. which very interestingly were biologically driven. So this is evolution progression over levels of atmospheric oxygen. We could also look at the concentration of reduced metabolites in the environment or biomineralization. This opens up the possibility, by the way, of self-organization at a higher scale than just physical, at a scale of interaction between the biotic and abiotic, and raises the question, does life itself drive the complexification of life by modifying the environment in a predictable, perhaps inevitable direction? I don't think the data are in on that, but it's an interesting question. Mm-hmm. Okay, lastly, in terms of preliminaries, what about the issue of gleaning trends from data? This has been a lot of discussion. Nils mentioned Stephen Jay Gould. And here the issue, Michael Roos makes an interesting point. He says that when Darwin subverted the notion of natural theology, that individual organisms were the result of, or offered evidence for intelligent design, theologians put a lot of emphasis then not on the individual organism, but on the direction of evolution. They wanted to infer design or purpose from that. So that question has become ideologically laden. And here's where Steve Gould comes in saying, well, there may be apparent trends, but they're passive rather than active. A passive trend would be just, in a sense, diffusion away from a wall. You saw what Nils put on the board. And an active trend would be biased replacement. Dan McShay has done some computer models of this. I'll point out B and C here. B is passive diffusion away from a wall. C is biased replacement. And the one thing I want to say about this is I think it's a red herring, actually, because the passive scenario actually isn't passive. So, for example, in diffusion, there's a driving force. So whether it's biased replacement or not, two things. There's a driving force, and we need to ask the question, what the driving force is. And secondly, in order for it to be able to drive, there has to be somewhere for it to get to. In other words, there are necessary preconditions or morphospace to grow into. And that's an interesting question. So whether it's what we call active or passive, it's still a trend. It's theoretically significant and possibly theologically significant as well. Okay, now let's jump in to the actual trends. And I want to quickly mention four. First of all, our physiological trends. I just think these are beautiful, actually. And what we see over evolutionary time is an energetic intensification, a homeostatic increase in homeostatic precision, an increase in sensory acuity, and an increase in biomechanical range. Fascinating paper just published looking at the evolution of the vertebrates. That just not even behavioral complexity, but just the number and kinds of movements based on the evolution of vertebrate anatomy increase over time. So here's an example, some examples. As we go from prokaryotes to eukaryotes to animals, we get a progressive intensification of energy expenditure. This is energy versus body mass, and as you can see, it goes up over evolutionary time. We don't know why, by the way. One possibility, as Nils mentioned, is that this driving force through selection to greater competitive ability. Another possibility is there are thermodynamic theories about why this happens. We don't know. But secondly, if we just look at within a group, this is the homeotherms. What we see is an increase in body temperature over time, given that reptiles, egg-laying, marsupial, and placental mammals, passerine, non-passerine birds. This is called maxothermy. We don't know why. And then if we just look at mammals, there's this fascinating convergence of body temperature. Even though they have different thermal conductivities based on their habitats, they end up with virtually the same body temperature. We don't know why. Secondly, there are trends in, there are lots of theories, by the way. When I say I don't know, we don't know why, I don't mean we don't have a clue. There are lots of fascinating proposals on the table. Secondly, issues of scaling, and I want to mention two levels of this. First of all is Cope's rule. Nils mentioned Cope's law. I think it might be better called a rule than a law, in keeping, by the way, with Nels's point of generalizations, but not necessarily prescriptive universals in biology. And of course, that's just the increase within lineages of size over time. Here's a famous horse example, recent work done with bivalves. Now the question is this a passive or an active or direction bias trend? And actually there are conflicting reports in the literature, but in a recent paper published in the Proceedings of the Royal Academy, there's an elegant experiment that looks at paired species within genera, older and newer, and found a bias toward larger species in the newer species. And if you look at this over time, if it was a passive trend, you find as many increases as decreases. But in fact, you find many more increases over time than you do decreases. So this paper argues for a bias trend, something pushing toward larger body size. Lots of debate over why that might be true. Lots of proposals. There are thermodynamic proposals which are uniform and actually don't involve selection. There are competing contrasting proposals in selection. It could be, for example, sexual selection. It could be contests over food. It could be because of energetic efficiencies and storage in larger organisms. It could be the ability to resist periods of food deprivation. Back to Nils's point, I actually think we're probably off base if we're looking for one single explanation, maybe a plurality of explanations generating a single trend. So take-home message here, it does look like there are biases, not just passive, at least in some cases, and it looks like there may be a plurality of explanations, not a single factor explanation. But secondly, with respect to co-school, then there are a suite of allometric variables that scale with body size. One of them, of course, is brain size. This might seem obvious, but in fact, some organisms clearly need to get bigger to get bigger. It's not clear why brains need to get bigger. You don't need to scale brain size to body size in order to do the things that brains do. And in mammals, for example, brains differentially increase. The forebrain gets bigger, but the lower brain is almost more relatively constant. This is fascinating. It might be my favorite graph in biology, actually. While bigger organisms have higher metabolic rates, it costs you more to have a pet elephant than it would to have a pet guinea pig. On a per gram basis, it's cheaper to be big. And this is, in a recent review article, described as the central theoretical question in comparative physiology. And we don't know why. And back to Nils's point, there's actually a variety. We don't know why doesn't mean we have no clues. It just means that there's a lot of argument right now. And some people are arguing that it has to do with internalist explanations. And other people are arguing it has to do with the effects of natural selection balancing life history strategies or how organisms spend their metabolic rate. In fact, there's not even agreement on the slope of these lines. There's a debate right now whether it's a power function of the 2/3 or 3/4 power. That turns out to be extremely important, by the way, in terms of influencing which explanation you take. But it's cheaper to be big. And concomitantly then, if your metabolic time slows down for larger organisms and they live longer. So if you look at body mass versus maximum lifespan, it simply goes up. This ends up being important in just a minute. And if you look at maximum reproductive rate versus body mass, at least in mammals, it goes down. So you have this wonderful thing emerging from allometry. Now, here's a trend worth thinking about theologically. That over evolutionary time, organisms are living longer and investing more in a fewer number. The capacity for intersubjective commitment and affiliative bonding goes up in evolutionary time, strictly as a function of allometry. And lastly, it's not just allometry. You see that there's spread around this line. And it looks like over evolutionary time, there's a bias trend toward down here. In other words, toward organisms living even longer and investing even more than size alone would predict. So, here we go, maximum lifespan versus body weight. Well, bats, birds, and primates are up above the line, and they're most recent additions. And in fact, keep your eye on bats and primates, because when we control for body size, then it turns out that bats, Chiroptera, and primates have larger metabolic investments in their young per unit of fecundity. That's once we take out the allometric of body size. Now, the significance of this is, again, bottom line, more investment in a fewer number with greater affiliative bonding. And I already showed you this graph of brain size versus body mass. That changes over time in terms of the intercept or the slope at which we're scaling it. It's called the encephalization quotient. And if we move from lower vertebrates, reptiles and fish, to mammals, to cetaceans, and the anthropoid apes, it goes up over time. Not only brain size, but brain size relative to body size is increasing over time. These are fascinating trends that just 10 years ago were lost in this vortex of debate over whether there were trends in biology. You with me? Okay, so summary. Increased capacity for internal control. Increased capacity to sense and respond to the external environment. Increased capacity for inter-individual investment. And most recently, you can make investments without attachments. Recent capacity for what Randy Nesse at the University of Michigan calls intersubjective connectivity. Those are profound trends, I think, related to complexification, but it puts some flesh on the bones of complexification. But what does it mean? And I want to close with some interpretive comments. First of all, on the passive versus driven issue, I think we really have some driven trends, but probably for different reasons, and not all trends are driven. Secondly, on Niels' point of the race of relating self-organization to selection, just two quick comments. First of all, I think his last two of the four are most prominent. Self-organization is constrained by selection, or vice versa. Those don't seem to me to be mutually exclusive. They could be checks and balances on that. But I'd like to propose maybe a compatible but slightly different way of thinking of it in terms of a hierarchy. Traditional Neo-Darwinism simply involves a mutation selection hypothesis. You can have hyper-Darwinism of Richard Dawkins or Dan Dennett. It's highly adaptationist. You can throw in contingency of Stephen Gould, but ultimately it's non-directional. It's maybe just teleologic. Next, you can take a step of mutation selection plus constraints. Constraints on mutations by biochemical possibility space. Constraints on selection by the information in the environment to begin with. That's the direction Simon Conway Morris is going. Next, however, you can throw in symbiosis as another source of novelty that doesn't necessarily involve mutation. That's Margulis. So two organisms coming together might not bring any new genes to the situation, but they bring new organic possibilities to the situation. But selection would still act on that knowledge. Next, still, you can have all of these, plus, and I'm an advocate of this view, by the way, although I think the data still needs more data. Mutation, selection, constraints, symbiogenesis, and directional interaction between organisms and the environment. Life creates the conditions that promote the escalation and complexification of life. That's a fascinating proposition. And then last still, and I'm a skeptic on this position, you can have all of these directional interactions plus feedback or regulation of the directional interactions. That's the Gaia hypothesis, suggesting that life interacts with the adiabatic environment in a way that is not only directional, but regulated. These three, B, C, and D, involve progress in evolution. This involves not just progress, but in a sense goal-oriented or teleological or purpose-driven evolution. There's nothing in Darwinism that is intrinsically incompatible with this, although I don't know how you would demonstrate this from the data alone. Okay, and I want to close with questions for Neil. One comment is, I think we need to distinguish between directionality in evolution, progress in evolution, and purpose. Directionality, of course, is just what the term suggests, what we talked about all morning. Progress would be, as Steve Gould said, actually, it would be directional trends toward in a valued direction. seems to me indisputable that we have at least some progress in evolution, and purpose, according to John Hott, is choosing a valued end. It has some sort of regulatory or feedback mechanism. That seems to me wholly unwarranted currently on the basis of the data. But even if we have progress, I want to suggest that that progress is morally ambiguous, so that we have this, the philosopher of biology, Hans Jonas, calls it biotic intensification, or ascent of soul. And it may even be the increased capacity for goodness, or intersubjective commitment, or love. But it isn't necessarily the increased inclination, because those very capacities actually can be used for moral evil. So I want to emphasize that this isn't a saccharine notion of sanctification through evolution. In fact, it may be the emergence of the need for redemption over evolution. And that would be my closing comment on trends. I would want to distinguish between a theological hope that somehow the capacity, but not necessarily the inclination for moral goodness emerges, versus on the other, on one extreme, a Dawkinsian nihilism that says the universe has precisely those properties that we would expect, that there's no good, no evil, no God, no purpose, nothing but blind, pointless indifference. That seems to be not the case. On the other hand, a Chardinian optimism suggests that just let evolution run its course and we'll get to the eschaton. That seems to be not only theologically but scientifically wholly unwarranted. Okay, questions for Niels. I'll make it quick. First of all, Niels, you speak often of self-organization, and I want to ask, at what level? Now, you seem to emphasize self-organization at the physical level, the initial boundary conditions, but it could be that we could have self-organization at the organismal level. The processes of development or ontogeny might involve self-organization. You could have it at the interactive level, organization emerging through symbiogenic interactions between organisms. You could even have it at the biosphere level, in terms of Gaia interaction. So what levels are you proposing for self-organization? Let me skip these and close with this. Your paper emphasizes, and this is one of the reasons why I wanted to emphasize the data rather than the underlying mechanisms. It emphasizes the mechanisms which drive complexification. And in a sense, I want to ask the question, well, what would theology look like? I'm not a theologian, so that's why I'm asking you. If we didn't worry about the mechanism for just a moment, and we just looked at the data, in a sense looking at the theme of the novel rather than debating how the author wrote the novel on a word processor or whatever else. And in fact, I want to ask if emphasizing the mechanisms over and against the theme is maybe in a way making the same mistake that intelligent design theory makes. IT theorists are so worried about how the cosmos is put together, but it seems like they never read the book to reflect theologically on the themes of the historical novel or pageant itself. And I know that is not your intent, but I'd like you to reflect on the theme, not the mechanism. Okay, thanks so much. It's been a pleasure to be with you. Thanks.
Thank you very much, Jeff. It's always wonderful not only to see details presented, but also to be aware of the things that you have not been aware of. I think that you have actually really by showing not only about mutation selection, not only about the restraints, there's also some biogenesis theory by Margulis about the whole ethical issues about how social connections are intensifying throughout evolution. I didn't have any data on this. I think that this is very, very important. I know that this is at the center of your interest also, where you are working also. So I'm just saying that this is that I think it's very, very important, and I think that as we go on, we become more and more essentially relevant also to the origin. There's actually difficult about discussing physics and Neo-Darwinian theory, because it's really, when we come to the community building and the interactive values that things are getting immediately interested in from a religious perspective. Now to your questions. First of all, I think that you're right that I should make a stronger distinction between directionality and progress. I used them actually. I didn't make any distinction there. I think that's correct. So that progress will be an evaluation of the positive evaluation of the directionality that has taken place. But it's very interesting because as we go along, we come to the Homo sapiens, it also seems that the kind of new options possible for humanity also means that something very bad is able to happen. So there's this moral ambiguity, as you are so rightly saying. I like that you're placing yourself in this between Dawkinsian nihilism and a Sharpian optimism, and speak about hope, which means that something new is going to happen. Then you have some critical questions to me, and the first is about self-organization. I think that when I've been talking about self-organization, I think it's really not even in the case of you read beforehand. I speak of it in a very general manner, using the issue that shows that's trying to talk about the principles of self-organization as opposed to design and as opposed to other ideas. But I think the question of levels is very important. The level that I've been interested in has been the thermodynamical level, which is really the level at which also Stuart Kaufman has worked, and also Ian Stewart has been working, also by took up in my atlas in the ISSR meeting in Boston here earlier. So I think that when I speak about physical self-organization, I really think about thermodynamics but I have been increasingly aware of the fact that we have in a sense to do with perhaps three different fractions of the self-organization debate. We have, first of all, those very general physical ones that do with the self-organization through physical matter, say the clumping of material through by virtue of gravity or thermodynamics. This is at the second. These are general features of self-organization. We want to understand how things can work on its own. We have to go back to these things. Then we have the computer models of self-organization. We can do PowerPoint, we can do Pierre Bax on self-organized criticality. These computer simulations are aimed to show that there are some general patterns, general forms at work whenever you have self-organization. So they can be models of forest storms or of earthquakes and so on. So this is the idea is here it should be rather scalable and applicable for a wide range of systems. So that's where I've been working. But then of course I see that where I really feel that self-organization can be talked about in a much more clear way. When you talk about modeling, empirical modeling of concrete systems, say ant societies, beehive societies, and so on. This is in this new book coming out by Kavalasi and others, a lot of authors from Princeton University Press, Self-Organization Biological Systems, which is full of these details. I think that here we are into something else, because here we have to do with a modeling of something concrete, not of general trends. So, and I think that probably it's much more likely that self-organization, that models of self-organization will be very interesting at these much more concrete levels. Often these self-organization models point to processes that are more or less, self-evidential. Say, there's more sugar there than here, and you have an ant walking in the middle, it will go over there. What is very interesting, it really reveals something new, for instance, about these trails that I'm making, which is very much has to do with pheromone. That there are specific rules because of specific thresholds for when they are having these initiating these cognitive feedback processes of amplifying a trait. So there, actually, I think that's something that can really something new that people don't know otherwise. So I think, in general, I think there is this physical level which is general, which is very interesting for theoretical reasons, but it's also very difficult. So it's a topic that are the general models, and then we have these much more theoretical models of self-organization that I'm working on now. So I think that this is where I've been working. There are probably many more spaces to fill out. Yes, I think that about the bipartite principle that I was not thinking too much about the mechanisms, more about the themes that come out. Interesting, this point was one that I made in the book that is out from Complexification, where I say that really what really feeds the religious interpretation of the universe and of nature are the results. It's really not a theory of life, but it is the life you see out there. These are the outflows of laws and not these specific causal mechanisms. So I agree with you that the main bulk of theoretical work should have to do with the outcomes of nature. But on the other hand, I'm also challenged very much by colleagues such as Bob Russell, never to forget the causal issue, and also from Nancy Murphy in particular. Never to forget the causal issue. Don't go too easily into a theoretical interpretation of what is there, but you have to understand how this fits into the causal center of the universe. And I want to take on this challenge, but I think that the main thrust of my own work is actually in interpreting, making what I call semantic explanations. Means how can things hang together? How can make a coherent picture of this? If through these thought experiments, where you say, if you happen to be a believer, if you for other reasons, not through science that we have come to believe, or whatever to say that, but if we have these presuppositions here, if you have these presuppositions here, how would you then read this? So it's kind of a thought experiment level that I'm mostly working. So I'm afraid to say that I'm doing perhaps even too much of what you really want me to do. Maybe I should really also be very clear and have a more robust thinking about the causal issues, which is very important.
Thank you, Niels. We have time for one or two questions before we break for lunch. With some brief and allow Niels to get a response.
You had a question earlier.
It's a minor point actually, but I noticed in your talk last night as well as your presentation this morning, you used the term law fairly frequently, and you were expressing doubts as to whether there were real laws of evolution, whether there were even laws of biology. And of course, first of all, I was having to kind of reprogram my brain every time you said Neo-Darwinism, because your definition was rather different from the way we use it in North America. So I was also working on reprogramming my understanding of law, because I think you're using a couple of different definitions there too. So I was curious as to what your definition of law was. But what do you think of, because what I was hearing was a much less flexible kind of description of scientific phenomenon than.
That's interesting.
What do you mean by law?
Well, by law, yesterday, when I talked about it yesterday, I mean universal prescriptive laws. And I think that I think that there are only few of these that can tell us a lot. Then we have statistical laws. Some of these are also, even though they are statistical, then their outcomes are so precise. The quantum mechanics so fine predictions, much better predictions than we can through a deterministic classical. So that's it. I would also count statistical laws as belonging to these laws of universal range. I must say that I have a much more descriptive view of laws myself when it comes to biology. and also when it comes to most of the what is called laws in physics, what laws about specific phenomena. So I think that one could make a distinction between universal and prescriptive laws, but I think there are only very, very few, and they may even be contested. But I think they are conservation of energy, thermodynamical law, gravity, and yeah.
Pretty precisely. I think that was the difference in what I was. My understanding of law is they are descriptive generalizations, which would actually include things like thermodynamics. Something like natural selection would be a law in the sense that it is a descriptive generalization. It tells you what will happen under certain circumstances. You get adaptive differential introduction under certain circumstances. But my understanding, my use of the term law, it is not, there are exceptions. And because it is, laws are constrained to explaining phenomena or describing phenomena under certain conditions. So in that case, evolution and biology in general, and most of science, would have laws. Of course, the laws aren't as important as the theories, so that's another.
No, I think that it would be difficult to talk about laws in this classical sense about biological phenomena. If you say about descriptive generalizations, that is law. I think that we have a very wide range of laws.
Exactly. So it's just a difference in definition.
I think it's a different definition, but I just read, I know we were working from some journal on education and mathematics or something like that, which really went through the idea of laws in textbooks in biology and just concluded it's a mess.
Oh, yeah.
And I think
Anytime we talk about textbooks, we got that.
Taking a brief consequence, right?
Yeah, I'd just like to hear something brief from both Eugenie and Niels on the definition of Neo-Darwinism. I got a little scared last night because I heard you distinguish between the Darwinian synthesis and Neo-Darwinism, and I'm thinking, did I get it wrong? Because I've been defining the Neo-Darwinian synthesis as a combination of Darwinian models and alien genetics and molecular biology. And I thought you were looking at them differently, so I'm wondering,
I think we have the same reaction. I think it's merely a terminological distinction. You were using the word Neo-Darwinism to refer to really the ultra-Darwinist, natural selection, Uber, all this kind of thing. Generally in North America, in biology and people who deal with evolution, Neo-Darwinism refers to that blending of Mendelian theory and Darwinian theory. And actually, what we are talking about right now in evolutionary biology is post-Neo-Darwinism, which is the integration of molecular, as well as all of the other factors that influence evolutionary change. But where we certainly are agreeing is a distinction between evolution as something that happens, that what Jeffrey was talking about, the patterns and the trends and the description of the data, showing that there has been this change through time of linked organisms and the mechanisms that bring it about. But we'll just have to remember how we are using these terms.
That's true. I'm quite clear how to find the footnotes in the text because I'm making this distinction based on David Weber's work on Darwinism evolving. And the difference being, I mean, first of all, Neo-Darwinism was first used about Arthur Weismann in this dialogue. So he was the first to be termed Neo-Darwinist. And then the question is, what happened to you in the 1920s? I mean, there was no marriage with Mendelianism in Weismann. So there was, yes, and there was no population genetics. So to answer your question, I mean, the two defining differences between Neo-Darwinism in this specific, and I was aware of when writing this paper that Neo-Darwinism is sometimes used much in a more broad sense, but the difference would be that what is added in the evolutionary synthesis is Mendelianism, first of all, and second of all, population genetics. So it is the whole statistical approach to evolution. So I think I agree that it's really about technology and following David Weber's more fine-grained definition, but maybe this doesn't make it too clear when I'm using it later.
We can handle it for next week. Just well, just remember what you mean
Let's thank Niels and Joe.
Nancy Murphy, professor of Christian philosophy at Fuller College Seminary in Pasadena, California. She holds a PhD in philosophy from the University of California, Berkeley, and a PhD in theology from the Graduate Theological University. First topic all I know. She is the author of numerous books and articles in theology and science. Her first book, Theology and Aims of Scientific and the chocolate students take note. Her first book earned the American Academy Wisdom Award. She's co-author with Catholic George Ellis on the book on the moral nature of the universe. By the way, that also is one of the 20th to CPS, together incredible scholars from these different disciplines to work together in collaborative projects to publish outstanding books like Orpheus and George. And they met at the Vatican System Conference for other reasons that came out of this. It's a wonderful model. She's also working with Warren Brown, H. Newton Maloney on Whatever Happens to the Soul, Scientific and Theological Portraits of Human Nature. The soul's gone. Nancy is a member of the board of directors of CPNS and an ordained minister in the Church of the Reverend Movement.
Thank you, Bob, for that lovely introduction. I've chosen to focus my response today on the methodology employed by Niels Henrik Gregersen in relating theology and the sciences. Gregersen's work has always impressed me, and my expectation is that we can learn some tricks of the trade by paying attention both to what he says about method and also by noting what he actually does in his essays. Now, I'm going to be drawing on more than just his lecture given this morning. He sent around several of his earlier papers, and so I've got some additional examples to draw from in trying to get a fuller picture of the way he does his work. So, Gregersen's methodological proposal. How might theology and science interact, according to Gregersen? First, he's made a distinction between two approaches to theology-science dialogue, which he calls explanatory and interpretive. An instance of the first would be to use a theological concept, such as divine creation and design, to explain the fine-tuning of the cosmological constants. Niels referred to that approach this morning as a causal approach. Gregersen does not reject this as illegitimate, but his focus is on an interpretive approach. This approach is based on the recognition that complex states of affairs are susceptible to a vast number of true descriptions. Theology and the sciences all provide a multiplicity of descriptions of reality. The most basic answer to the question of the relation of theology and science is then to say that science provides resources for enriched theological description. Gregersen accepts the widely shared view that theological language is not reducible to scientific language. He puts it this way: when redescribing a reality which is already partially described in terms of the sciences, we should not expect full translatability between science and theology. Similar to the way in which ethics provides a new perspective on reality that does not merely reduplicate factual statements, so does religion provide a new language in order to catch important differences in reality, namely, qualities that are conformal with God's identity, such as generosity, humility, love, and features that run contrary to God's identity, such as small-mindedness, pride, aggressiveness, despair. There is, in other words, a semantic surplus, a lingua nova of religion that transcends that of science, end quote. More particularly, he says, it is distinctive for religious language that the world as known by everyday language and by the specialized languages of the sciences are re-described under the aspects of God's good creation and sinful distortion. Thus, Gregerson's interpretive approach to theology and its interaction with the sciences focuses on the qualitative aspects of nature that are open for a religious interpretation, which seeks to discern a divine presence in the details of nature. It asks, how do natural processes express the characteristics of the God that is at the center of religious worship? Science then has an indirect and heuristic impact on theology, not direct and normative. A case study, complexity and divine action. I've provided a very brief account of what Gregerson says the theologian should do in relating to science. Let us look now at one example of what this theologian actually has done. When his description of science theology dialogue is left out, is the fact that this particular theologian has made immense contributions to the description of nature itself. Gregerson recognizes the extent to which theology and philosophy of religion are still often in the grip of the Newtonian image of nature as a clockwork, and he has done an impressive job of marshaling resources for a revision of that image. He begins, as in his paper today, by surveying controversies in evolutionary biology. Then he surveys theories that stand on the borderline between science and philosophy. These are theories regarding the structure and functioning of self-organizing systems, complex adaptive systems, and autopoietic systems. From all of this, he proposes a grander picture of evolution and of nature itself. Quote, a world in which in some respects is fixed and balanced, regulated by natural law, yet in other respects fluid and beyond balance, poised at the critical boundaries between order and disorder, end quote. So while the world does contain clock-like systems, it is largely made up of systems that have the capacity for self-creation. Gregerson then goes on to ask what value this redescription of scientific reality may have for theology. An obvious consequence is the end to notions of creation in which all entities are the products of pre-established design. A more interesting application is to take the notion that self-organizing and autopoietic systems represent the development of increasingly complex orders of being, or free. That is, natural processes, given enough time, will tend toward increasing complexity without outside intervention. Can we use this notion of order emerging for free in theology, he asks. One example, Gregerson redescribes the kingdom of God as a self-creative process involving the immanent activity of God in an open-ended and self-creative world. God may be described as the immanent one who invites people to openness and self-creativity. When they respond, a fragile new order emerges in human, social, and political life. Now, dialogue with Robert Russell's method of creative mutual interaction. Russell has provided one of the most detailed and sophisticated accounts available of possible routes for theology-science interaction. Based on Ian Barber's earlier work and on the notion of theology as the topmost science in the hierarchy of the sciences, an idea owing largely to Arthur Peacock, he has suggested 8 legitimate paths of influence from theology to science and science to theology. The first 5 are legitimate ways for science to inform theology. The last 3 are ways in which theology may inform science. And I'll start with a diagram of Bob's own that's pretty hard to read, but you can see a schema that shows interaction among models, theories, data within the sciences, a similar interaction within theology, and then a variety of paths by which various components at the theology level can interact downward with science
and various ways in which science can interact upwardly with theology. These 8 paths are: 1, scientific theories may serve as data that place constraints on theology. 2, scientific theories may serve as supporting data for theology insofar as they are explained theologically. 3, philosophical interpretations of scientific theories may serve as data for theology. 4, scientific theories may serve as data for theology when they are incorporated into a philosophy of nature. 5, scientific theories may function heuristically in theology by providing conceptual, experiential, practical, moral, or aesthetic inspiration. 6, theology may provide some of the philosophical assumptions underlying science. 7, theological theories may function heuristically in the construction of scientific theories. And 8, theological theories may lead to selection rules within the criteria of theory choice. That is, for choosing between existing scientific theories that all explain the available data, or for deciding what set of data the theory should seek to explain. Now, clearly, it seems to me Gregerson's work is best classified under Russell's 5th path. That is, scientific theories function heuristically in theology by providing conceptual and other sorts of inspiration. A question then for Niels. Do Russell's first 4 paths, involving scientific theories as data for theology, fit what you call the explanatory approach to theology and science? And does an interpretive approach, if it is seen as the only legitimate one, rule out paths 1 through 4? A second sort of question. What's your judgment on the legitimacy of paths 6 through 8? You say near the end of section 2 of your paper today that theologians, not being experts, should in general avoid the cherry-picking of scientific theories and stay with the generally accepted scientific theories, now in parentheses, unless they themselves are driven by metaphysical motives. That is, unless the scientific theories themselves are driven by metaphysics. This leads to the obvious question of what the theologian ought to do when there does appear to be a metaphysical motive for scientists embracing a particular theory. Might it be the case that theologians are sometimes in a better position to recognize metaphysical assumptions in science than the scientists themselves? Sometimes outsiders to a field can see things that insiders are too close to see, like the glasses on the end of our own noses. And it's also the case that theologians are much more likely to have studied metaphysics than scientists are. So, perhaps in addition to Russell's path number 6, not only the provision of philosophical assumptions, but also critiquing philosophical assumptions embedded in science, and thereby influencing the evaluation of scientific theories. A helpful concept here comes from my pet philosopher of science, Imre Lakatos. His description of scientific research programs, he describes them as organized around a core theory that is often metaphysical in nature. Now, if theologians are better at spotting the metaphysical assumptions already at play in scientific research programs, might they also offer heuristic assistance to scientists in envisioning different metaphysical starting points? This is my own reformulation of Russell's 7th path. Is this, Niels, a legitimate example? You said this morning that Simon Conway Morris's work is maybe motivated by his Christian commitments. Whether they are or not, we could ask, what if they were, and still pursue the same question. He went on to say, but then the science has to stand on its own feet. It has to stand on its own terms. Isn't this actually a beautiful example of path number 7, which is theological theories may function heuristically in the construction of scientific theories, or to put it in my terms, might provide the core metaphysical assumption that gets played out in the development of sub-program within biology. So in short, Niels, on the basis of these few phrases, can I persuade you to embrace more of a two-way relation between science and theology than what you say in your own methodological proposals? Closing reflections. However much Gregerson may wish to eschew some of Russell's paths, I come to the same conclusion regarding science and theology methodology from reflecting on these two scholars' contributions. This is the necessity of recognizing a role for philosophical reflection as mediator between theology and science. Russell makes this explicit in paths 3 and 4, recognizing the role of philosophical interpretations of scientific theories and the intervening role of philosophies of nature. Now, I suggest that while Gregerson has not mentioned philosophy in the brief accounts of methodology I've summarized here, his actual method of doing theology and science involves a very significant role for philosophical redescription. The example I employed shows Gregerson to be deeply involved in a sort of philosophy of science that consists in reflecting philosophically on controversies that emerge within science but cannot be settled by science alone. He goes on to employ these results in hinting at what we might call a new worldview or world picture. The concept of a worldview is rather vague. Another possibility here is Stephen Toulmin's concept of a cosmopolis, a conception of the human social order as a microcosm modeled on the cosmos itself. Toulmin writes, for example, about the role of Newtonian science in providing timbers for a new cosmopolis after the medieval synthesis was dismantled. Still another possibility would be the concept of a conceptual scheme, a useful idea in philosophy, so long as it does not suggest that there is ever any single, consistent, unified scheme. Part of the job of philosophy is to attempt to discover and interpret a culture's conceptual resources and to recommend ways of putting them in better order. All of these reflections lead me to suggest a wider account of the relations between theology and science, one that includes more specific attention to philosophy and to whatever it is we mean to get at in speaking of a world picture or a worldview or a cosmopolis or a conceptual scheme. All three sorts of discipline, theology, the sciences, and philosophical subdisciplines such as metaphysics and epistemology, contribute to a subculture's worldview and also draw metaphorical, conceptual, and other sorts of resources from it. Thank you.
You have kindly already sent in the response to my paper before it was ever done, and I think I really like that. You are a prophet and a philosopher and very efficient American theologian. Thank you. I think that it's true that I have been thinking about. I think that there's something of a witchcraft or what does Wittgenstein talks about bewitchment of language in the English word's explanation. So white American colleagues, they are explaining everything. But when they're explaining, they're just saying something about it sometimes. Other times they are really going to a causal explanation. So that's why I'm trying to make a distinction between causal explanation, where I think that which is very important, and then semantic explanation, putting things into a bigger picture, putting them in perspective, putting them perhaps into what you call a conceptual scheme. And I think on this point that there is a risk of a theology which is only interpretive, meaning that is trying to be floating in the sort of cream of interpretive cream on the top of everything, while not really being rooted in reality. There's also, however, a problem in wanting to have a causal explanation only, and then raise a lot of explanatory claims which are not very easy to redeem. So I think we should be on both sides. So that, but I'm just wanting to say a word of caution that often we actually engage in semantic, what you call interpretive. You asked me where am I on this on this chart of very helpful chart by Bob, and I think that I would be able to move to take many of the. Could I just have this line on, because I only have the scheme. I brought the scheme with me, but without the explanations. Well, I think first of all, just to bring up some of your latest point, I'm very worried about worldviews in the sense that we can bring them in too early. So in the present paper I did on contextual coherency theory in this book on rethinking theology and science, I try to make a distinction between data, theories, thought models, metaphors, and worldview as 5 avenues in which you can have a discussion between science and religion. And I try to say that I'm afraid that we're too prematurely jumping into the worldview issues. So I'm much more happy about what we call the conceptual scheme, which I think is more in tune with what I really want to do. Whether I'm able to achieve it or not is another issue, of course. But like a sort of conceptual scheme saying, clarifying what are we doing and what are the relations between what we're saying here and what we're saying there, and also to try to bring in some sort of unitive scheme, which would be what I call semantic explanation. Also, I mean, also when Ticket's point also in relate to Philip Clayton's first book, Explanation from Physics to Theology. I think that you're also pointing out that the idea of explanation is being contextualized in modern philosophy, and often it simply means making sense. This is exactly what I mean by semantic explanation. But now back to this issue. Yes, definitely does place constraints on theology. I think that this is even at the core, number one is even at the core. You see, I believe that theology is a big discipline than the theology that can be entertained in the scientific dialogue. So there will be a lot of theology which should be done with very respectful work, but which is not affected by science fiction. I mean, if you are going into science fiction, we should be constrained on theology. I think one can give many examples of that, and I think that what we talked about teleological models have been gone out of use in theology, at least in my own Protestant theological tradition. I mean, I don't think there are very many traces like of the old style teleology or design theology. So I think that's very easy. Supporting data is, I think, very close to what you listened to, close to number 5. I think that heuristically, of course, is only inspirational. I don't hope that I'm just being inspired by science, because if I'm addressing scientific discussions in my way of doing theology, then I think at least I am both constrained by and may find supporting data for my theological work within the scientific dialogue. So at least 1 or 2 are easy.
Maybe instead of using the word data, which implies an epistemological relation, maybe what we want to say is that science provides a first-order description of reality, which is then addressed for the theological redescription. So maybe you, instead of accepting or rejecting these categories, maybe you want to reformulate them to fit an interpretive model better than an epistemological model.
That's interesting. You mean supporting data? Now data would be something like religious experience, would be something like, I think what Bob has as data would be scripture, tradition, reason, and experience. So I think what I really think is that a specific, in my term, it would be that specific scientific theories will then support or criticize specific developed theological theories. So I think it's very important that our theories on one side don't go from scientific theories to some some primitive concepts or experiences on the side of religion. I think really that we should take theology serious as a set of theories that have a certain internal logic which is able to illuminate some specific problems, whereas other problems will be blacked out. So maybe that would be my point there. Of course, philosophical interpretations are simply much easier. So what we're doing in reality often is that you are thinking science through philosophical pictures. So when I speak through Daniel Dennett, that he's a philosopher, he's not a biologist. So this is actually what we are doing. And I think it also goes for point 4, that it's not very often that I read scientific articles. I read maybe science or nature, but I don't really read into the specific. So usually, I think all of us, also by way of our limitations, have to use this philosophical reflection on scientific theories as that which constrains or supports and gives heuristic ideas to all. So I think 1 to 5, I think I would more or less be there altogether. And I don't think that this has so much to do with the distinction between interpretive work versus explanation or semantic explanation versus causal explanation. I think, how did you, why did you link this interpretive to one of these issues?
Because of basically the role of the word data in all 4 of those, because that is suggesting that the science provides epistemological justification for the theology, whereas I would think you would say it provides that about which one theologizes.
I think that's probably true. And so that in that sense, if you understand data as something lending specific support for specific view, then I understand why you feel that I might not be in point 1 and 4. But then I think maybe we should have fun.
We're not talking about you behind your back, but playing in front. Out there.
Examples. 1, Copernicus. 2, Big Bang, for people like reasons to believe. 3, blocking inverse versus slowing time for relativity for the problem of time in Whitehead. 4, Whitehead, laws of nature. 5, inspiration, Starry Night. 6, history of science is based on ex nihilo plus reason from Greece. 7, Fred Hoyle. So an angry Big Bang, steady state. 8, who you choose, Fred Hoyle or steady state? They're both simple example.
But then I think that in the way you describe it, then I think that I would be on the 1 to 5 without any problems. In the sense as described by Bob.
Okay.
But if you mean that science can be incorporated into theology, specific data lending specific support for a specific view in a more empirical sense, then probably I don't think that this is very vital, or I don't see very many examples of that. Maybe you would mention one. You mentioned an example for a specific data that supports a specific theory, scientific theory that supports data in theology.
Niels, that whole organization reasons to believe, say Big Bang equals or improves ex nihilo. I don't think it's true.
But we shouldn't use that. We shouldn't use examples what you think of as rather.
So I just need to use data and answers for theology and take it seriously. It's not construction.
That means that it should be taken into account that the important object for that is the trust by theologians in respect for the scientific theories about these phenomena. This is enough. I'm there.
Well,
Yeah.
a relevant example for my current work is neuroscience, theories about the brain being the basis of our mental life, has a direct impact on Christian anthropology. Well, I shouldn't say direct, it certainly supports a physicalist account of human nature in Christian anthropology. But of course, you have to go via philosophical interpretations of neuroscience research. But I do think of neuroscience research as actually providing data in a plain old straightforward sense for physicalist anthropology.
We need to be mindful of time, so.
Yeah.
Maybe, okay, I think that questions might be raised to Nancy, but we don't have any other questions. The time is up.
We have one or two questions.
Thank you, Nancy, very much.
Thank you. That's convenient, you can stay on schedule.